A couple of questions. So let's go from current slide. And what's that? Oh, yeah. Picky, picky, picky. Okay, where's it? Okay, I think that's going to come on now. But I've got to find where I am here. I think we did this slide before. Maybe not. Okay, so I'm on about the right page. Okay. So let me back up. Ha, that looks like a good place. Okay. All right, we're going on page 44. This is 1.4 exercises. And number 9, you said? Very good. Okay. It says in this exercise, to which sets of ordered pairs represent functions from A to B. So they first give you set A, which is 0, 1, 2, and 3. Okay? And B is the set -2, -1, 1, 0, 1, and 2. Okay? Now, what do we call set A? The what? Domain, exactly. And what do we call set B? The range. Okay? And here are 4 options here. It's going to take me a while to write these. The first is a set 0, 1, 1, -2, 2, 0, and 3, 2. Okay, the B is 0, -1, 2, 2, 1, -2, 3, 0, and 1, 1. Okay, the C option is 0, 0, 1, 0, 2, 0, and 3, 0. Okay, and the D option is 0, 2, whoops, 3, 0, and 1, 1. Okay. Now the question is, in these 4 options here, which set of ordered pairs, A through D here, represents functions from A to B? Okay? Let's start with the first one. Okay? 1, 0, is that a, 0, 1 if I could read, is that a potential element in the function A to B? 0's in A, 1's in B. That fits. How about the second? 1 is in A, -2 is in B. That fits. How about 2, 0? Yep, that fits too. And how about 3, 2? Yes. So this is definitely represents a function from A to B. Okay? Now, let's do the B one. 0, -1, is that an option? Yep. 2, 2? Yep. 1, -2? Yep. 3, 0? Yep. 1, 1? Okay? Is that a function? Say again? Say it one more time.
In the domain, 1 is repeated.
Yes, okay. From the domain, 1 is repeated here with 2 different answers. Now, if they had a 1, negative 2 here, that's just redundant. It's okay. It's just redundant. But 1, negative 2 here and 1, 1 there, not a function. A relation for sure, but not a function. So B is out. Okay? We're doing problem 9 on page 44, the 1.4 exercises. Okay, C. Is that an option? 0, 0? Yes. 1, 0? Yes. 2, 0? Yes. 3, 0?
Yes.
Yes. But can you have the same second answer always? Sure you can. It's a constant function. So this is a function. C is also a function. A is a function. B is not. B is not because of these 2 elements here. This assigns a negative 2 to 1. This assigns a 1 to 1, not an option.
Okay, so you said in the domain. Okay, hold on.
Okay. Any element in the domain can only have 1, and only 1 element from the domain, from the range.
Okay, but it's different from the range.
Oh, yeah. You can have the same range element repeatedly as many times as you want to.
Okay.
Okay? How about D? 0, 2 an option? Yes. 3, 0 an option? Yes. 1, 1 an option? Yes. So is that a function? Okay? I ask you to turn back, consider the evidence here. Okay? Turn back. Let's see. Yes, to page 35, if I can read. Bottom of the page, characteristics of a function from set A to set B. The first characteristic there. Each element in A must be matched with an element in B. And we don't have 2 matched with an element from B. Okay? Some elements from B may not be matched with A. Yeah, that's fine. 2 or more elements in A may be matched with the same element in B. Yes, we saw that. An element in A, the domain, cannot be matched with 2 different elements in B. We saw that. So this is not because it does not assign every element in A. That's a little picky, but that's what the result is. Now, in the back, I'm afraid I'm going to lose my computer here. Okay, how did it say? Huh? Say again? It's not one. Okay, so A and C are your functions, right? Is that what it said in the back? Okay. It's 1, 4. Takes me a while to find it. Sometimes I argue with the book.
It's on A78.
78? I'm close.
A78.
Got it. I was 1 page away. Come on, sit down. Have a seat. 170, 880, isn't it? Whoa. No, A82 in mine, but maybe the structure is different. Addition is different. This is number 9. Function A, not a function because, okay. C is a function, and D not a function because not every element in A is matched with the element for B. See that? So we got it, and for the right reasons. Okay? B not a function because element 1 in A corresponds to 2 elements, negative 2 and 1 in B. So that's not a function. I'll move one of these spare pages back there, so I don't have to look around this hard. Okay. what it was, people got here early and had questions, so I went on and started the recording. So if you got here later than they did, you can still pick up what we did. Okay. Were there any other questions on homework? I don't even know what time it is now. I didn't get on my watch.
8:25.
Okay, we still got 5 minutes, so I'll answer questions once class begins. Well, I'll answer questions before class. I answer questions after class. Anytime you have questions, I'll answer them. Okay? Any others? Second? No others? Okay. If not, can anyone need this left up here a little bit longer? Yay or nay? No? Okay. Then I will, let's see. Here we go. All I have to do is hear everything we said. All right. Any other questions before we get going? Homework? Any questions at all? All right. If not, I had skipped over example 2 in the text. They didn't have it in the slide set, so I missed it. And it's a very important example. So let's go back and do. Example 1 was so easy. And they tend to do this sometimes. I mean, this author's pretty good. But sometimes it seems like they show the easy ones and skip the hard ones. So let's do example 2. It's not that it's that hard, but it's just a completely different kind of example. So if there are no other questions, let's go on and do number 2. Well, all right. And number 2 is one of these. It seems like, yeah, this is the first one we've hit this way. You can go to larsonprecalculus.com, absolutely free website, for an interactive version of this type of an example. Now, the guy told me he was going to get it to me, and I haven't seen it yet. Let's do a pause right now for just a moment. Hey, can I get your name, please? Jateria? Okay. Is that what you go by? I didn't circle you last time. Jateria. Got it. Okay. Let me do a quick pause here. If I do anything quickly, we're going to come back to this in a bit. I wanted to do something else right now while I'm thinking of it, because some of you had asked about it, and I want to get it out there. I talked with the guy at Cengage last Tuesday after class. He said he'd get them to me. I didn't see them Friday, but let's see if they came in over the weekend, the codes.
You have it paused.
What's that?
You have it paused.
Well, I want y'all to read the code off of here, okay? Let's go to email. Okay. I don't know why the password is not correct. Huh. Have they changed my password without telling me? That's my username. This is freaky. Let me try this. Nope. This is bizarre. Okay, let me try typing everything over again. I can't get in my email. I'll have to figure out that. So I can't answer your question about what's the code because they've changed my email address, my email login. And this is totally strange. So they probably sent me an email telling me they had changed my email. No, just kidding. All right. I can't get it to you today, but as soon as I get to the office, let me get your name, please.
Corey.
Corey. Jacory, right? Do you go by Jacory or Corey? Jacory, okay. All right. And this is a dumb question, but were you here Thursday?
Yeah, I was there.
Huh?
I was there every day.
Okay. I think you came in late, and I already circled you, and then I couldn't tell whether the circle was absent or the circle was present, so that's why. Yeah. See, I had marked you instead of, I think I put Josh's in yours because I got off the line, and then you came in later, and I didn't know which one was right. Okay. So, let's go back to this. I had just done a pause here and tried to get my email to see if they had sent me the code yet, and my email won't work. So let me set up with a pen. Okay, and name please. Cammy. Okay. Good deal. Good attendance so far. We're just missing Ty, Daquan, Katie, Raquel, something like that. Kayla, Amber, Mel, and Kiara. Okay. All right, we're doing example 2 on page 37. And as I was saying, LarsonPrecalculus.com is an absolutely free website. You don't need any code or anything else to go to it. And you can see an interactive version of this type of example. And it's determined whether each equation y represents a function of x. So here's the A one. X squared plus y is equal to 1. Now, some of you might be able to look at that and say yes or no. Does that represent a function of x? Generally, I don't trust myself to do that. What would you do? You want, say again? Plug in a number? Okay, we might be here a while then, because there's a lot of numbers out there to plug in, as in from negative infinity to positive infinity. Am I going the right way? Say again? Okay, solve for y. Okay? So how would we do that? Subtract x squared from both sides, and that gives us, these go away, y is equal to 1 minus x squared. Right? Now, what was that one phrase to remember? In this course, I said if you got that down, say again? A little louder. Y is equal to f of x, okay? Remember that. Y is equal to f of x. Looks like we got it, folks. Now you can imagine plugging in numbers, and whatever x you put in there, you're going to get how many y's? 1 and only 1 y, because y is equal to that. No matter what x you put in there, you're going to get a y value. Maybe you can see this up here. If you can, more power to you, okay? But written this way, I see for absolute certain, no matter what x I put in there, I'm going to get only 1 y, right? So this is a function. Y, it can be written, that y written as a function of x. Okay, how about the b part? Here we have minus x plus y squared is equal to 1. Not too far off from what the other one was. Guess what would we do first? Say again? Add x to both sides. We're going to try to solve for y, just like we did before. So add x to both sides. And that gives us, this goes to 0, y squared is equal to 1 plus x. Very good. But I want y, not y squared. So what do I do take a square root of both sides. And that gives me a y here is equal to what?
Square root of 1.
Square root of 1 plus x. So close, but not quite there. Plus or minus, anytime you take the square root of both sides of an equation, you have to put a plus or minus. Because you see, if this were a positive value, whatever that is, 1 plus x, say that x is 3, so 1 plus 4 would be 2, square root of 2 would be 2, and square root of 4 would be 2, so y would be 2. And the reason for that is 2 squared is equal to 4, okay? But down here, if this were a minus 2, and you square that, you still get a 4, okay? So anytime you take a square root of both sides, you have to put a plus or minus sign. Now, is y a function of x? Say again? Yes, okay. Well, the one I just gave, when x equals 3, then y could be 2 or negative 2. What's wrong with that picture? For 1x, you get 2 possible y's. This is not a function of x. It's a relation for sure, but it's not a function. Okay? That, by the way, and you don't need to know this ahead of time, this would be something that looked like this. Okay? And didn't we do vertical line test already? Fails the vertical line test. Be a plus 2 or a minus 2. Not a function. Top one, yes. Bottom one, no. Plus or minus is what did it. Did us in there. Now, after every example, and I think I forgot to mention this last time, there is a checkpoint. Okay? The checkpoint has 2 other examples, very similar to the ones you just did. And this one has audio-video solutions in English and Spanish at larsonprecalculus.com. Same places you can go to see the worked out interactive version of the thing. So there's a great website to go to. So we don't have time in class to do all those. That would be, in my mind, the very first thing to do once you get out of class. If you have another class, then go to that class. But if you have a free period or sometime or another, whenever you can sit down and do it, go and do the checkpoints first, then try the homeworks. Because the checkpoints you can check at larsonprecalculus.com. If you have a computer handy, not go to the library or some computer lab somewhere and do that. All right, good deal. Any questions? Okay. Now, I think we did that slide last time. We did that slide last time. And, we didn't do this one, though, did we? I think we left off on this slide right here. Had we done all the substitutions? Seems like we had, right? Yeah. Okay. So we're ready for the next slide. And maybe next slide, they did the substitution. Got the same answers we did. Did we do this one? No. Okay, I couldn't remember doing it. Although f is often used as a convenient function name, and x is often, as everybody's favorite independent variable, they don't have to be that way. You can name your function anything you want to. It doesn't have to be f, and you can make the independent variable any variable you want to. It doesn't have to be x. Okay? You can use other letters. Now here's a function, f of x, one of our favorites. What this says is take that value of x, whatever it is, square it, subtract from it 4 times it, and add 7 to that. Okay? Now here's another function, f of t. And that says take whatever t you put in there, square it, subtract 4 times it, and add 7. That's the same thing as that, isn't it? So guess what? It really turns out that independent variable is just a dummy. You can put anything in there and it still works just the same. Okay? Or you can name the function g and the variable s, and you say take the g function says take what's here, square it, subtract 4 times it, and add 7 to it. That's the same thing you did before. So that g of s is the same as alpha t is the same as alpha of x, because the function is doing the same thing. Whatever variable you put in, as long as the operations are the same, they're the same functions. They all define the same function. In fact, the role of the independent variable is that of a placeholder. And I remember one text I taught from said, you could put a stickman in there. F of stickman is stickman squared minus 4 stickman plus 7. That works too, okay? Anything you want to put in there, you can. It represents the same function, as long as the operations are the same, okay? So here you could just leave a blank. Alpha blank is equal to blank squared minus 4 blank plus 7, okay? That works too, okay? A function, so basically whatever you have, you want to put in the blank, you can put it in every place and it comes out. That includes numbers when you're evaluating a function just like we did before. Function defined by 2 or more equations over a specific, okay. This should be on another slide. They put it on this slide. The graphics person got sort of off base here, okay? Because that goes in just a minute. We're going to do example 3 first, okay? Whoa, we're not going to do example 3, are we? Okay? Let's go back and do example 3. We'll do it here. Okay? Let g of x equal to minus x squared plus 4x plus 1. Find each function value. First, g of 2. Guess what we do? Say again? Plug it in, just like Glade, right? So what do we plug in? How do we do that? Write down the minus sign. That would be 2 squared plus 4 times 2 plus 1. All right, very good. Now we run into a dilemma, don't we? How do we do that? Say again? Okay. I heard negative times the negative. Everybody agree with that? Not quite. Have you ever heard of, say again? Okay. Are you saying you square that first and then negate it? Okay, everybody agree with that? Anyone agree with that? That's it. Okay? Remember, please excuse my dear Aunt Sally. I don't know what she did, but please excuse her, okay? Okay, she's old and the crap. No, I'm sorry, we won't get into that. What does that mean? Do parentheses first. We don't have any parentheses. I put one in here. That just means multiplying that. We didn't have any parentheses here. And then what? Exponents next. You do your exponentiation before you do MD, multiplying, or that's my dear, multiplying or division. Or lastly, addition or subtraction. That negation sign is like a subtraction. So you do the exponentiation first. So if you wanted to really drag this thing out, that would be minus 2 squared is 4 plus 4 times 2. Now you can do multiplication. That's 8 plus 1. Okay? Now, addition, subtraction, in whatever order you find them. Okay? Now, technically, that would be minus 4 plus 8 is plus 4 plus 1 is 5. When they're all additions or subtraction, here's how I like to do them. combine, do the like signs first. 8 and 1 is 9, minus 4 is 5. That works too, okay? So you don't have to do them, well, follow the rules, but this one is definitely not a negative 2 squared. To be that, you'd have to have this in parentheses. Then that would be negative times negative is positive. But without the parentheses there, you exponentiate first and then negate later. Okay. All right. See why I said this was an important, well, that was the previous one, but this is also an important example. How about this? G of t. What would that be? Like a rhyme every time. This is incredibly easy, folks. Minus t squared plus 4t plus 1. That's all there is. Plug it in, plug it in. Now this next one is going to take a little more effort. So can I erase the previous two? Okay. So let me, everybody got those. Does anyone need them a little bit longer? Okay. I'm really lazy. I'm going to erase just as little as possible. I found out I'm wearing out my screen by erasing all the time, but okay. Now, the third one says this. G of x plus 2. What in the world do we do with that? Say again? Plug it in. Everywhere you see an x, you put the minus sign first, and then you put a x plus 2, then you put the squared, tell me, plus 4 times x plus 2 plus 1. Got it. Now you got to do the math, right? Okay, so let's do it. What do we do first? The exponent, okay? So square first. Now, does anyone know the shortcut for squaring a binomial? Say again? You may have said it right, I just can't hear well. Okay, it's going to start with an x squared. I'll buy that. Plus what? Okay, there's certainly a plus 4 there. But have we gotten everything? Okay, if you don't know the shortcut, what's the other way to square anything? X plus 2 squared. What does that mean anyway? X plus 2 times x plus 2, right? That's what it means to square something, multiply it by itself, right? So how do we do that? Foiling, okay. And foiling is first. What's that give you? X squared. That's where we got it before. And then what's after first? Outer, which is plus 2x. Then we got inner, which is another plus 2x. And then we have last, which is plus 4. Okay, in addition to having a smiley face, we have the right answer, don't we? Okay, that's why he's smiling. All right, what does this give us? X squared plus 4x plus 4. That's what we left out before, plus 4x. Okay, now, I'll give you the shortcut. Okay, whenever you're squaring a binomial, square the first term. We did it, just like we got there. Twice the product of the two terms. Here's the product of the two terms. They're the same terms. So twice that would be plus 4x. The product of that is 2x. Double that is 4x. And then you square the last term. That's exactly what we did there. That's what you do every time you square a binomial. So the shortcut is you can just write it down. But if you don't remember it, work it. Okay? Always work it. And if you doubt your memory, work it, okay? It doesn't hurt, okay? After doing it enough time, you'll say, okay, I'm tired of doing that. I'll remember it. Okay. What's next? Plus 4x plus 8 plus 1. Okay, we've still got a little work to do. What's that? Yeah, you distribute the minus sign in, and what does that do? Minus x squared minus 4x minus 4. Continue. Plus 4x plus 8 plus 1. Now, if you want to add 8 and 1 to the other, you could. Okay? Now, what do you notice happening here? Combine like terms, and what's the first one you see? Negative x squared. There's no other x squared term. But then what do we have? Minus 4x plus 4x adds to 0. And then, what do you wind up with? Plus 5. Got it. There's g of x plus 2, x squared plus 5. Doesn't look at all like your original g function, but that's what it is. G of x squared plus 2. See, these really important ones like this, they sort of tend to leave them out sometimes. Other times they'll do them. Now, if that's a little fuzzy to you and you need more practice, as soon as you can after class, do the checkpoint. You have 3 there to do, and you can find the audio-video solution at precalculus.com. There's another larsoncalculus.com. Don't go there. You won't find it. Okay, now we pick up that next statement. Forget this. See, that's where the example 3 went. Here, when a function defined by 2 or more equations over a specified domain is called a piecewise defined function, because it's defined one way at one place and another way at another place. Okay? And that leads directly to example 4, which we have here. Evaluate this function. Here's the function. It's x squared plus 1 for all x's less than 0. It's all negative x's. And it's x minus 1 for all x's from 0 to positive infinity. Have we left out any x's? No. Our domain is all real numbers, but you have this function for the first half, or this side, and that function for the second side. Okay? And it says, evaluate this function here when x is equal to negative 1. Okay? So we're doing f of negative 1. Now here, the first thing we do, it sounds a little dorky, and it is, I admit it. Where are you, Waldo? Where are you? If x is negative 1, are you in the upper function or the lower function? Second? Really? When x is minus 1? Minus 1 is less than 0. Here you are, Waldo. Y'all know where you are, Waldo, do you? Okay? So you're here. So you use this function. And what does that give you? How do you do it? Negative 1 squared plus 1. And what's that? 2, okay? I was wanting you to say 1 plus 1 equal to, let's say, high-level math today. 1 plus 1 is 2. All right, we got it. All right, let's do the second one. When x is equal to 0, f of 0. Where are you, Waldo? You're in the bottom, because here x is equal to 0, you're down here. Okay? So what do we do? Yes, 0 minus 1 is equal to minus 1. Perfect. Y'all are good at this. And then how about when x is equal to 1? What's your f of 1? You're in the bottom again. 1 minus 1 equal 0. Got it. Way to go. Okay. Any questions on that? So when you have a piecewise defined function, you have to first figure out where you are. Are you in the first part, second part? They could have 3 or 4 parts, 5, 6, 7 parts, okay? Find out which part you're in, and then use that formula to figure out what your function value is. Does that make sense? All right. So, all right for me to erase? Okay. Let's see how they do it. Because x equals -1 is less than 0, you're in the top part. So you use f of x equal x squared plus 1. And you would obtain f of -1 would be -1 squared plus 1, which of course is 2. Okay, so y'all went right to the jugular. Y'all were reading the book, weren't you? Never mind. Okay. Now, for x equals 0, you're not up there anymore because 0 can't be less than 0. 0 is equal to 0, so you go down to the second part, x minus 1, but put in a 0 there. 0 minus 1 is -1. And then the third one, x equals plus 1. Obviously, you're in the second part there, so it's 1 minus 1 is 0. Good deal. Any questions on that? And there is a checkpoint. Please do the checkpoint soon as you can after class. Okay? Now, they skip example 5 and 6, which are two of the more important examples, and here they skip them. Okay? So let's go back and, let's do them here. Okay. Can't get any more white space. For all real values of x, or find all the real values for x for which f of x is equal to 0. You're looking for x. Find all x's that make that true. When, in the a part, f of x is equal to minus 2x plus 10. Okay? How would you do that? One way would be start plugging in numbers. Okay? And because the domain is all real numbers, you may have quite a problem on your hand, right? But guess what? Good mathematicians are what? Did I tell you this, my theory? Maybe not. I find that a good mathematician has to be just a little lazy. Do any of you qualify? Oh, okay, we got some budding mathematicians here. The rest of you hard workers, you can still do it. Don't fret. You can still do it. Because what I mean by that is always try to find the easiest way to do the problem. Be lazy about it. Find the easiest way to do it, as long as it's correct, and see if we can do. So rather than plugging in numbers, which is the brute force method, let's just, what does it tell us here? F of x is equal to 0. This says this is f of x, so guess what we do? Set it equal to 0, because f of x is equal to 0. Now solve that equation. No longer a function, it's an equation now. We can solve that. How would we solve it? A little louder, I couldn't hear.
You write it as 0 equals -2x plus 10, and you subtract 10 from each side. And divide by -2.
Okay, divide everything on both sides by -2? Is that what you said? No.
Subtract 10.
Oh, subtract 10 from, okay, I can't hear. Subtract 10 from both sides. Both answers were correct, by the way. Okay, and this gives us -2x is equal to -10. Okay, and then you said divide both sides by -2. Okay, and that gives us x is equal to 5. Okay, now I had a professor in grad school in Fourier analysis, I think it was, and he used to like to say this. The student would say, okay, yes, I've got the answer, fine. No, the pupil would say, yes, I've got the answer, fine, let's move on. The student would say, on the other hand, as opposed to pupil, let's make sure that's right. So let's plug this in here and see if we indeed get 0. And it's really easy. -2 times 5 is -2 times 5 is -10 plus 10. Yes, we got it right. Okay? That was the A part. Let's see if we can do the B part here. And by the way, it said find all the x's. That's the only one. We found it. Okay? How do we know it's the only one? What kind of equation is this? Anyone know a name for it? Second? Okay. I know what you're talking about. It has a slope. And what has slopes? Line. So this is what kind of equation? Linear equation. What makes it a linear equation? The exponent is 1. And when you have an exponent that's 1, that means in general you can only have one solution. You may have no solutions, but you can't have more than one. So let's do the B part here. The B part is f of x, different f of x this time, is equal to x squared minus 5x plus 6. Okay? Now, what kind of equation is this? Anyone know the name for it? We haven't gotten there yet. I just wondered if you knew. It's called a quadratic equation. Maximum exponent is 2, which means we could have up to 2 solutions, no more. May not have but one or may not have any, but you couldn't have more than 2. So we anticipate finding maybe 2 solutions. But how do we do it? Same instructions. Find all the values for x's that make f of x equal 0. So what do? Set it equal to 0 because that's your f of x. And then what do? Okay, now you could, but that's sort of a hard way. And I'm too lazy to do that. Okay? What would you try first? Let's factor it. Now, I don't want to offend anybody, and tell me if you find this offensive. Okay, I won't do it if you do. But when I ask in this class, what's the F word, it's going to be factor. Exactly. Okay, is anyone offended by that? Okay, so in this class, the F word is factor. Okay, so we're going to try to factor it. Now, how do we factor? I have a dumb way of expressing that. You don't have to go vote mine. When we're multiplying, remember when we did it before, multiply the two together, what do you tell me method do we use? Foiling. So I call this unfoiling, okay? So let's start with the first term. What's the only possible factorization for x squared? X times x. Got it? Now, here we misspell a little bit. We go to the last term, but all we're interested in at first is what's the sign of the last term. And what's that? Plus. What does that tell us about these two signs? Second? They both got to be the same. They both got to be the same. So you look at the middle one to see what it's got to be. And what is that? Minus and minus. Okay. Now we ask ourselves what two numbers multiply to be 6 and add to be minus 5. So you got the minus 5, so add to be 5. 2 and 3. I think that'll work. Okay? 2 and 3. Now, I always check it because, the student says, okay, I factored it. The pupil says that. The student says, let's check it. Okay, x times x is x squared. That checks. And outer is minus 3x. Inner is minus 2x. That adds to be minus 5x. Way to go. And last is minus times minus is plus. 2 times 3 is 6. Yes, we got it. Okay, but what does that tell us? Second, you have two answers, and what are they? X equal 2 or X equal 3. Now, do you see how she got that? She just popped it out of her head with no, okay. How did it get it? Well, the only way you can have two numbers multiplied together, these are just numbers, two entities multiplied by each other give you 0. What does that mean? Only way you can get two things multiplied by each other give you an answer of 0 is one of those has to be 0. There's no way in the world you can multiply any two other numbers in the world together and get 0. You won't. One of them has to be 0. It's called the zero product principle. So you first set that equals a 0. X minus 2 equals 0. Add 2 to both sides, you get x equals 2. Then you set this one equals 0. X minus 3, and it's or. They don't have to both be either or x minus 3 equals 0, or add 3 to both sides, x equals 3. That's how we got that. So we got our two answers, and let's see if they both work. Okay? 2 squared is 4 minus 10. 4 minus 10 is minus 6. Plus 6 is 0. Perfect. How about this one? 3 squared is 9. Minus 5 times 3 is minus 15. 9 minus 15 is minus 6. Plus 6 is 0. Don't be losing your minus signs. You'll get wrong answers. Okay. All right. Good deal. So either x equal 2 or x equal 3. Guess what, folks? There's a checkpoint. Please, after class, do the checkpoints. Go to LarsonPrecalculus.com and check and see if you get them right. All right. They also skipped example 6. Ready for them to leave this one? Okay. Example 6 is a slightly different kind of problem, but still somewhat similar. It says find all real values of x. So we want to find our x's. Okay. Okay. For which f of x. Oh, this is the same type problem, isn't it? No, I'm sorry, I'm looking at the wrong. I found all the real values of x for which f of x is equal to g of x. Huh? When a f of x is equal to x squared plus 1 and g of x is equal to 3x minus x squared. Okay? How are we going to do that?
Would you just plug in f of x for g of x?
Okay, and what do you mean by that?
As in put in x squared plus 2.
Okay, so x squared plus 1 is equal to 3x minus 1 minus x squared, right? Because this is your f of x, that's your g of x, and this says they're equal to each other, so put them equal to each other. Right, perfect. And now what do we do? Second? Okay. Okay, I know what you mean by like terms. Usually when we say that, we mean combine like terms. Well, first, you got to get them on the same side, okay? And when this is a quadratic or higher, get everything on one side, 0 on the other side, okay? Now, which side do you want to go to? Left to right or right to left? It really doesn't matter much, but I'm lazy and I have a preference. Let's go from right to left. Let's add x squared to both sides. Okay? Now you want to do the other at the same time, or you want to do it in 2 steps? Texas 2-step or 1-step? I don't care. Anybody? Huh? 1 step? So let's go on and subtract 3x from both sides. It doesn't matter where you put it. Okay? So, these go away. No, they don't. I just added them. Okay? So it did matter where I put it a little bit. Okay, I can't read my signs. Okay, this gives us a 2x squared, right? Minus 3x, I should have put that in between, plus 1. And what do you get over here? 0, which is exactly what you want. Why? Because we have a quadratic. Okay? And what might we try? All right, good deal. Y'all are on to it. Let's see if we can factor. This one might be a little more problematic because, what's your first question? It's only factorization for 2x squared. And what will that be? X times 2x. Okay. Now, we still look next at the sign of the last term. That's a plus. What does that tell you about these two signs? They got to be the same. Look here, and they, again, got to be minuses, don't they? Okay. Minus, minus. Now, here's where you get into trial and error. Okay? Now, you want two numbers here that when you do it, you're going to get a -3 there. Well, I'm sorry. Well, no, there's not much, no question at all, is there? Because the only possible factorization for 1 is 1 and 1, right? So either this is going to factor or it's not going to factor. Let's see if it factored. Get out of there. Okay. Let's see if that was correct. X times 2x is 2x squared. Good for you. Okay. Then we do the outer and you get a minus x. The inner gives you minus 2x. When you combine those, you get minus 3x. That's good. And when you do the last, you get plus 1. Yes, that works. So what does that give us as our solutions? X equal 1 or x equal, I have to do some work on this one. What you think? Let's pull up here and do 2x minus 1 equals 0. How would you solve that? Add 1 to both sides, and that gives you 2x equal 1. Divide by 2, and that gives you, say again? X equal 1/2, right? Got it? Okay. Let's check it and see if those two work. Now I want to go back to very original problems here. So let's do x equal 1 plus 1 squared. Plus 1 is, high level math again. So this is a 2. Let's do the same one over here. 3 times 1 is 3 minus 1 squared is 1. 3 minus 1 is 2. Yes, we got them both. All right, now the tough part. The fraction. Okay. So let's do, and someone say, I don't even want to check it. Well, check it. Is that not the bit? 1/2 squared is? It's what? Oh boy, maybe we shouldn't check it. Okay. What's 1/2 squared? What does the square mean to square it? Multiply. Oh, what did you say? I thought I heard it. 1/4, exactly. And 1/4 plus, how many fourths is 1? 4/4. So this is 1/4 plus 4/4 is 5/4. Okay, so this side is 5/4. Let's do it over here. Okay. 3 times 1/2 is?
1/6.
Say again?
1/6.
Woo. Maybe we shouldn't do this one. Okay. All right. 3 times 1/2. If I think in terms of food, folks. So let's picture I have pizzas down here, and I cut them in half. And I do 3 times 1/2. How many pizzas do I have? 3 halves of a pizza. 1 whole pizza and another half, right? I think in terms of food. Okay. So this gives you 3 halves minus. We already did that one. 1/4. How many fourths is 3 halves?
12.
Woo! How many fourths is 3 halves? Okay, let's take that 3 halves of a pizza and chop them into 2, and now we got quarters of a pizza. I'm sorry, I did it wrong. Take half up, yeah. Yeah, that's what I was saying. Yeah, chop those in 2. How many quarter pizzas do I have? 2, 4, 6, yes, think in terms of food. So this is 6 halves minus, 6 fourths minus 1/4 is 5/4, same as we got over here. Okay, good deal. All right, sometimes you might not want to check. All right, no, you should. Okay. All right, we got that one. That was the A part. I don't have room for B, so let's do B. Let me erase what I can here. Anyone need this a little longer? Everybody got it? Okay. Let's do B. And we got the same F. No. Not quite the same. I'm being really lazy, am I not? Okay. G of X equal, I'll erase all that. All right. Probably would have been easier to erase it all and rewrite it. But I thought they were using the same functions. They're not. Okay. So this is now the B part. F of X is equal to X squared minus 1, and G of X is equal to minus X squared plus X plus 2. Did I copy it right? I hope so. And what do we want? Yeah, alpha of X equals G of X, so you plug them in. Alpha of X is X squared minus 1, and that's equal to G of X, which is minus X squared plus X plus 2. Now what? Yeah, okay, and how do you do that? Add X squared to both sides, and subtract an X from both sides. I'm going to squeeze it in somewhere there, and subtract 2 from both sides. Okay, what happens on my left? X squared plus X squared is? Help me, folks. It's what? 2X squared minus X, because that's the only one there, and this gives me negative 3. And over here we got 0. Good deal. Now what do we try? Try factoring if we can. Okay. What's the only possible factorization for 2x squared? I left off my squared. What's the only possible factorization for 2x squared? Second? X times 2x. Okay, now this is the one we have a little bit of problems with. We go to the sign of the last term, and that's a minus. What does that tell you about these two signs? They're different. So one's plus and one's minus, but we don't know which is which. So this is where trial and error comes into play. How you want to start? Pick one. Plus, minus, or minus, plus. I don't care. Second? Plus, minus. Let's put a plus here and a minus there. Now, what's the only possible factorization for 3? 1 and 3. So, want to do it in that order? Okay, let's check it and see if we factored it right. No guarantee we did, but let's try. X times 2x is 2x squared. That one part's okay. The outer gives us minus 3x. The inner gives us plus 2x. Y'all were looking in the book, weren't you? Okay. Oh, you lucked out and got it the first try. Okay. Minus 3x plus 2x is minus x, and then you get a minus 3. If you hadn't gotten the signs in the right place or the numbers in the right place, try again. Okay. So we got it right. So let's go from there. What are our answers? X equal -1, or X equal 3 over 2. All right, everybody see how we got that? Anyone need to see that worked out? 2x minus 3 equals 0. Add 3 to both sides. That's 2x equals 3. Divide by 2, x equals 3/2. And now what you've been waiting for, checking it, right? Minus 1 is pretty easy. Minus 1 squared is 1 plus, or 1 minus 1, I think that is now, isn't it? 1 minus 1 is 0. Okay, let's check over here. -1 squared is, wait, -1 squared is plus 1, but then you got the minus in front, which makes it a -1. Plus a -1 is
0.
And that gives you 0. Y'all are quick, okay? That would give us a -1. That would be a -2 plus 2 is 0. Good. Now do the part you've been waiting for. Okay. 3/2 squared is 9/4 minus how many fourths is 1? 4/4. 9/4 minus 4/4 is 5/4. Hey, they're stuck on 5/4, aren't they? So they got 5/4 over here. Let's see about here. Let's see. 3/2 squared is 9/4, but negate that, you get negative 9/4 plus, how many fourths is 3/2? 6/4. So negative 9/4 plus 6/4 is negative 9/4 plus 6/4. Negative 3/4. And how many fourths is 2? Say again? 8. And that would be negative 3/4 plus 8/4 is 5/4. Yes, yes, yes. Way to go. All right. Got through that one. All right. Good deal. Any questions on that? And by the way, there's a couple of checkpoints down there. Do your checkpoints as soon as you can after class. Okay? How are we doing on time? Ooh, we got some time. Let's move on. Any questions? I need to leave this a minute or two longer. Everybody got it? Any questions? Okay. Now we're going to talk about the domain of a function. I thought we had already talked about this, but we're still going to talk about it some more. Okay? The domain of a function can be described explicitly, as in, here's the domain. Okay? Or it can be implied, that means implicit, by the expression used to define the function. That's a pretty nebulous statement. We'll get a little more meat on it. The implied domain is a set of all real numbers for which the expression is defined. Okay? Now, where will we always start? We're going to start with assuming all real numbers, unless we find exceptions. And then the exceptions we have to exclude. So that's how we're going to do this. We're going to assume all real numbers unless the expression says, not defined there. For example, this one. F of x equal 1 over x squared minus 4. Now, where do you assume to begin with? Domain of x? All real x's, unless something in this problem says you can't do it. And what are a couple of things you can never do in math? Ever do it in math. Say again? You can never divide by 0. And whenever you see the variable in the denominator, you have to make sure that is never 0. So here's how I do it. The book does it slightly differently. When I see this, I immediately come here and say x squared minus 4 cannot equal 0. Okay? Because you can't divide by 0, right? Then, guess what we do with this? It's a quadratic, so what's the F word? Factor. This cannot equal 0. Okay? Can we factor x squared minus 4?
Yeah.
How? X, what? X, what, say again? X plus 2 times x minus 2. Correct factorization. Okay? And if that can't equal 0, that means that either x plus 2 cannot equal 0. And it's not an or now, it's an and. Because it cannot equal x minus 2 cannot equal 0. So what does that tell you? Add 2 to, or subtract 2 from both sides, and that gives you x cannot equal okay, did I go too fast? You can't read where I'm writing. X cannot equal negative 2, and over here, x cannot equal positive 2. So those are the two values you have to exclude. All other real numbers are fine, but x can't be positive 2 or negative 2. So you can either write the answer this way: x has an implied domain consisting of all real numbers x other than x equal plus or minus 2. Now there's two shorter ways to give that, okay? And those two values are excluded from the domain because division by 0 is undefined. Can't divide by 0. So here's the two ways you can express. You can write a sentence like that. That's sort of long, and I'm too lazy for that. So here's the other way. It's the set of all x's such that x is not equal to plus or minus 2. Now that says exactly what that says, but it just puts it in set notation, okay? And the vertical lines being such that the set of all x's, all real number x's, except x can't be minus 2 or plus 2. Now the other way to write this, and this is what the book likes a little better, though they haven't introduced it yet, and I'm going to bring it to you slowly. Let's just imagine we have our number line here, right? And this is going from negative infinity to positive infinity. I have to do my arms the other way for you. Okay, here's your 0. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here, all those numbers except x cannot equal plus 2 and x cannot equal minus 2. So we put open circles there. Everything else on this side is good, everything else in between is good, and everything on this side is good. Okay? Now that's not how I suggest you write it, but this is how I suggest you think about it. Then you say, this is called interval notation. Interval notation uses parentheses, and it's sort of unfortunate because ordered pairs use parentheses. Lots of things use parentheses, but they do. This is, out here, is negative infinity. So open parentheses, negative infinity, comma, go up to, but not including negative 2. Now, how do you indicate it does not include negative 2? You put a parentheses. If it did include negative 2, that would be a bracket. Bracket means you include the number here. Parentheses means you do not. This is not a number, so it's always preceded by a parentheses. That just means it keeps going negative. Okay? Now we union that with, tell me what would go next. Everything from, no, minus 2. Because of that parentheses, you don't include the minus 2, but you got to include everything up to it, like negative 1.5, negative 1 3/4, negative 1.99999999999. That's all there. So you have to just do lazy way, parentheses, negative 2 up to 2, followed by parentheses, because it doesn't include 2. Union that with,
2 to
second,
2 to infinity.
I can't hear.
Parentheses,
Parentheses, 2 to infinity. Parentheses. Perfect. That's called interval notation. To me, I don't really care for it much, but the book loves it, okay? I like this method a lot better. That's pretty concise, short, easy, says it all. This is what the book usually likes. This one, they just wrote the sentence. X can't, all real numbers x other than x equal plus or minus 2, which is exactly what the first one says, and it's exactly what this says, because from minus infinity to positive infinity is all real numbers, except you've excluded minus 2 and plus 2. Okay? They all say the same thing. Okay. Now, what's the other thing we can never do in mathematics? We can't ever divide by 0. Can you think of something else that you can just never do? Square root of what? Of a negative number. You cannot take the square root of a negative number, so therefore when you see an expression like this, you look at that and say whatever is inside the parentheses, and here it's just x, that cannot be negative. Now, how's a little more positive way of saying that? Right here. X is greater than or equal to 0. Okay? Rather than putting a not in there, say it is greater than or equal to 0. Because any number, 0 will work fine. No problem. Any positive number will work fine. 0.1, 0.01, 17 million. Anything positive will work. Anything negative will not work, so x has to be greater than or equal to 0. Set of all x's such that. So, my way of writing would be the set of all x's such that x is greater than or equal to 0. That says it all, folks. Okay? The way they do it in interval notation, again, picture your number line. They don't show you this, but I think it's helpful. There's your 0, and there's negative 1, 2, 3, 4, 5, and positive 1, 2, 3, 4, 5. Okay, now, all x is greater than or equal to 0. That would include 0 and everything greater. Okay, nothing over here. So this would be an open bracket, 0 going to positive infinity. What you close that with? Parentheses, because infinity is not a number. So that's how they got this. 0 with the open bracket, meaning you count the 0, nothing to the left of 0, but you count 0 and everything to the right. So this way it's a little shorter to write this. I still sort of like that better. But I'm a dinosaur. Okay, that's how I learned to do it. Okay. In general, the domain of a function excludes the values that would cause division by 0 or that would result in the even root of a negative number. Because it's not just square roots. It can be 4th roots, 6th roots, 8th roots, 10th roots. No odd numbers like the 3rd root, 5th root. Those are fine. You can take those roots of negative numbers, just the even roots. Okay. And the index shows that. Now this is one thing, by the way, that if you don't see it, it doesn't mean 1. If you don't see a coefficient there, what do we assume it is? 1. If you don't see an exponent, what do we assume it is? 1. If you don't see an index here, what do we assume it is? 2. Because this is a square root symbol. If it's not a square root, they'll put a little thing like the cube root, 5th root, 8th root. They put a little index up there. So if you don't see an index, you assume it's a 2. Everything else, if you don't see, you assume it's a 1. But square roots are 2's. Okay. Oh, sad, isn't it? We're running out of time, aren't we? Okay. Sorry about that. We should have gotten a little further, but we'll begin next time with example 7. Okay? Now, we made decent progress, but I talked too much. Let me get my thing in place. Okay, let's do some homework exercises. Again, you can do either 5 or 7. They're both a calc chat. And by the way, we did notice in the back of the book, they don't just have the answer sometimes. They actually tell you why, okay? Sometimes, okay? So other times they just have the answer. So 5 or 7 are but in the back of the book. The answers are they're worked out at calc chat. Number 7's even more worked interactively at calc view. Number 9's at calc chat. Any of the odds 11 through 17 are at calc chat. 11's at calc view. Any of the odds 19 to 29, okay? They're all at calc chat. 21's at calc view. Either 31 or 33, they're both at calc chat. Any of the odds 35 to 41, they're all at calc chat. That's just like that one example they didn't have in the book, okay? 37's at calc view. Either 43 or 45, they're both at calc chat. 43's at calc view. And then you can start working if you want to at 47 or 40, a couple of those. But we didn't do the example, so you can stop at 45 and we'll pick up.
Okay. It's on page 44.
Pages 44 and 45.
Will you give the numbers again?
Second?
Will you give the numbers again?
Okay. 5 or 7, 9, any of the odds 11 through 17, any of the odds 19 to 29, 31 or 33, any of the odds 35 to 41, and 43 or 45. Is that too fast? Sorry.
Will you say any? One?
Say again?
Just one of the any? Will you say
Okay. All right. I would say do any of them. If you do one, especially if it's not the easiest one, and you got it knocked, say, hey, I got this, let's move on to the next one. Okay. Or what I think I would do is do one of the easy ones, say, okay, I think I understand this, let me do one of the harder ones. If I get that one, I'll move on to the next group. That's how I would do it, but you do it however you want to. I want you to do enough till you understand what they're asking for. All right, good deal. Any questions? Good question, by the way. All right, we'll see you on Thursday. And we'll pick up right where we left off. I think we'll finish 1.4 finally and move on from there. Good deal. Ty never came in. Oh, let me. I'm sorry.
Are you taking up our homework?
Only if you want me to review it. That's up to you. If you're getting it, that's fine. That's good.